Hey, this is lesson 16.5. We're talking about scientific notation. It starts on page 738 in your textbook if you're following along. And the study tip here does say scientific notation is used to write very small numbers and very large numbers. All right, key idea. Scientific notation. A number is written in scientific notation when it's represented as the product of a factor and a power of 10. Okay, the factor must be greater than 1. The factor must be greater than or equal to 1 and less than 10, which means it needs to have exactly one non-zero digit right here. Okay, if it has one non-zero digit before the decimal, then you know it is greater than or equal to 1, but less than 10. And then it's multiplied by a power of 10. So here we have a number that is greater than or equal to 1 but less than 10, okay, 8.3, and it's multiplied by a power of 10. The power of 10 can be a positive or a negative power of 10. So the first thing it's example is just identifying numbers written in scientific notation. Look at the first one. Is it in scientific notation? Well, look at the number. Does it have exactly one digit in front of the decimal? Yes, it does. Is it multiplied by a power of 10? Yes, it is. Then it is in scientific notation. The second example, example 1b here, this number right here does not have one digit in front of the decimal. Remember, it has to be a non-zero digit. It does not have that. This number is less than 1. So not in scientific notation. Even though the rest of it looks good, this part makes it not scientific notation. The second key idea is writing numbers in standard form, the way we normally write them, from scientific notation. So the absolute value of the exponent indicates how many places to move the decimal point. So if we look back at those two that they just showed us, if we're just looking here, we would have moved this decimal 6 places, and we would have moved this decimal 8 places. We just look at that exponent, and that tells us how many places we move the decimal. Because remember, multiplying by 10, we move the decimal 1 place. Dividing by 10, we move the decimal 1 place. And that's how many tens we're dividing by or multiplying by. If the exponent is negative, move the decimal to the left. Now, I can't remember if we're moving it left or right most of the times. I just know if it's a negative exponent, I'm making the number smaller because I'm dividing by 10 that many times. And here, if the exponent is positive, move the decimal to the right, because if it's a positive exponent, then we're multiplying by 10 that many times. So we're making the number bigger. All right. Then they give us a couple of examples. Here we had 3.22 times 10 to the negative fourth. Well, they're giving it to us in scientific notation, so we know it's already in scientific notation. But it is worth a look here. One digit in front of the decimal. That makes it scientific notation multiplied by a 10 to some power here. So this tells us we're moving the decimal 4 places, and we're making the number smaller because of that negative. So we'll take that decimal and we'll move it 4 places to the left. The first place moves it on this side of the 3, and the next 3 places we're going to have to insert a 0 to hold that decimal out there. So our number becomes 0.000322. We don't drop off these digits here. We just leave them on to the end. They put a 0 out front. It's not needed, but it sure is nice when we've got a decimal number like this to put a 0 in front of that decimal, just to draw attention to that decimal a little bit more. And then for the second one, we've got 7.9 times 10 to the 5th. It's a positive exponent, so we will be moving this decimal to the right 5 times. So we take 7.9, we take that decimal, we move it 1 spot. The first spot's going to move it to this spot of the 9. The next 4 spots, ding, 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 we have to put zeros in there to hold the decimal out. So if we move that 5 places, it would give us 790,000. All right, well, that's about it. Now let's do a couple of the on-your-own problems. Well, for those on-your-own problems, number 1 just says, is 12 times 10 to the 4th written in scientific notation? No, because this number right here has more than one digit in front of the decimal. It's got 2 digits in front of the decimal there. That makes it not scientific notation. So no, because this factor right here is greater than 10. Remember, it has to be greater than or equal to 1, but less than 10. So this is a no. So for number 2, now we're taking these numbers and writing them in standard form. 6 times 10 to the 7th. Now it looks like, hey, is that just one number in front of the decimal? Yeah, because remember that decimal goes right there. If it's a integer, a one-digit integer, sometimes you can't see the decimal there, but it is there. So we take that. This 7 means I'm moving the decimal 7 times. And because it's a positive 7, I'm moving it 7 times to the right to make this number bigger. So 6, the decimal was here, so I'm going to move it. Every time I move it, I'm putting a 0. 1, 2, 3, 4, 5, 6, 7. Put in my commas, 3, 3, 60 million. Number 3, 9.9 times 10 to the negative 5. Negative 5, so I'm going to move the decimal 5 spots, but I'm moving it to the left 5 spots because I'm making this number smaller because I'm dividing by 10 5 times. So the first spots that I move, it's going to put on this side of the 9, and the next 4, I'm going to have to put a 0. So 0 point, and then there's 4 zeros, 1, 2, 3, 4, and then my 9, 9. Just to double check, if I move this 5 spots back, 1, 2, 3, 4, 5, yep, I get back to my original factor. Finally, number 4, I have 1.285 times 10 to the 4th power. So I'm moving that decimal 4 places, making the number bigger, of course, because it's a positive exponent. And the first 3 take care of these numbers, and then I've got one more spot, so I'll have to just put 1 0 on there. 12850. Put it in my decimal, and I get 12,850. Excellent. There you go. That was pretty quick and easy lesson. You can go and do your journal page, which I believe is 386, and have an awesome day.